Hi everyone, welcome to session 2. Okay, so I think yesterday or like last time we did we get some integer n and we got the sum of its digits, and we also have another problem that we did, and that was just getting an n and doing the sum of all the multiples of 3 or 5 that is below n. So let's ask again for two more questions. ChatGPT again for two more questions. Yeah.
I think it should follow the context, so I don't know. You can just say, give me another, like you can,
Give
so
me-
that give me another beginner. Yeah, so I would think it will bring the context more into the discussion.
Yeah.
Or ChatGPT.
Yes.
And it will hopefully be different.
Yeah. ChatGPT, sure. Okay. Palindrome check. Okay, I think I just got it, but let's just check if I'm not thinking it wrong. So what is this? We got a palindrome. A palindrome is a word, phrase, number, or other sequence of characters that reads the same forwards or backwards, ignoring spaces, punctuation, and capitalization. Okay. Okay, that's cool. So you want to just check if a string is palindrome or not. Okay, easy. So you're saying you're ignoring spaces, so we'll remove spaces. We'll also remove punctuation. I will also remove capitalization. So that's easy, I guess. What we can do, and yeah, we just say yes or no. So yeah, good. So let's open it. Yeah, RV is good. Say chat palindrome. That's yeah, palindrome. Yeah, palindrome check as ChatGPT has given us the name of the problem like that. So let's get iostream header file. Yeah, we also want the string header file, and we also want one more, which is CC type, which is going to allow us to make characters lowercase and check if they're letters or numbers or both at the same time. So like we can do that. So now where is it? Yeah, so first you want a string s, so let's get that. So it's std string called s, and we'll say std cns. Okay, and a little like swipe check. Okay, how am I going to do this? Like ignore spaces, so remove spaces, remove punctuation, and lowercase every single letter that you have. Okay, so you also have numbers, but I think that's fine. Like if you do lowercase on a number, it will not do anything. So we can say for auto c in s, we'll say if c, like we want characters, right? We want letters, yeah, and numbers. So I think there's a is alpha num. Yeah, it's alpha is alpha num. Yeah, al num, and we need some character c. So if it's not a number nor a number, so not a number nor a letter, then we just remove that from the string. Okay, I don't know how to remove characters from a string, so I think we just need to erase. I mean, yeah, after all, strings is just a vector of strings of characters, so we say s dot erase. But what will you erase? Okay, we want an iterator called where. Okay, so if you really want an iterator, I'll do that. So but the iterator will get messed up. Okay, yeah, so not cool. How am I going to do this? Yeah, I think I got this. So we could say we will call it std string not compressed, refined. We'll call it refined s. And yeah, why do I have this extra underscore? Okay, so we'll just say simple if c, like if it is an alpha num, if s, like no, not s, the string, the character is a alpha numeric character, then we say refined S plus equal to lower of C. So the to lower works as like if you have a capital letter, then we are going to make it lowercase, and lowercase will stay lowercase, and any other character will stay that character. So if it's a number, it will stay a number. If it's a lowercase character, it will stay a lowercase character, and if it's an uppercase, then it will become a lowercase, and put that in S. So let's first check this really quickly. So actually see out S as S. That's one thing, and we say STD see out refined S is refined S, and done. We also return 0 really quickly. Okay, yeah, good, yeah, good. So let's go here with a G++ minus O checked palindrome check, chat palindrome check dot slash chat palindrome check. Okay, so let's see, let's have 1 2 3 Q W E R T Y, and then dot slash square brackets spaces, done. And oh yeah, true, it will not allow spaces. That's not good. So yeah, that's not good. So how am I going to do this? So okay, so we are not allowing spaces, but we need to get spaces as well. So maybe there is a way. So would I get multiple sentences for now, sentences in a string C++. See what we get. To read multiple lines of text in C++, we can use the getLine function with a loop. But when will we stop? Okay, so maybe I have a way. I think we can do it like this. That maybe we can store each character or sentences in a vector of strings, and then club it into one string after defining every single string. That could work, yeah. So we need some like null character where it will stop our thing. And how would we do this? Maybe you could just put a /0 as like string, null string or something. So we can say const string called stopster is equal to /0. Okay, so when we get S, so we'll say do something while S is not S but sentence, I guess we just call it sentence. Sentence is not equal to our stopster. Yeah, that works. Yeah, we also need sentence, so we get that. So we just need another string, I guess. So string sentence, yeah. So how am I going to do this? So I need to get the string, check if it is a stop string, and then I have to put it in. So what if I just make it like a while true, do while true? Does that make sense? Yeah. So we just have a forever loop, sort of. So we get our s, then we say if s is equal to stop stir, then we say we break. So the do while loop is complete. And if not, then we say s plus equal that sentence. Yeah, so actually, yeah, get the sentence and then actually get the sentence. So get the sentence if sentence is equal to stop stir, then we want to stop. Otherwise, we want to put it inside string. After that, then we'll process our string and make it smaller or something. Yeah, good. Let's see how this works. But no, it also put one more thing. Let's really string. No, not wait. Let's really see out. Sorry. Yeah. I don't know. Me a like. Give me multiple sentences that when given I will club them in a well, I'll club them and tell you if it is a palindrome. Yeah. God, that's really big. Okay. Oh wait, I forgot to put the less than operator. Okay. I'm also saying that put /0. Oh, okay. Or I'll say like this. Put stop stir to stop giving more sentences, something, and then we'll start. Good. Something. Progress. So give me multiple sentences that when given, okay, I will club them and I'll tell you if it's a palindrome. Okay. Put this to, oh, okay, yeah, I got it. Size 0 is an empty string, so yeah, fun. How am I going to do this? Like slash, how do I? Maybe I just make an HTML tag, I don't know. Will this work? HTML tag, yeah. If that's correct thing, okay. Okay, yeah. So yeah, the /0 is a /0, so yeah. It's a bit difficult. So /0. Maybe I put a colon. No. You know what? I just put the normal slash. Just yeah, work with this. I don't want /0. So yeah, and good. Okay, finally, give me multiple sentences that I'll give. Then when given, I'll club. Okay, I don't care about the sentence. Okay, put /0 to stop giving more sentences. Okay. So what if I say pop KLLLL? Oh wait, not like this. So like hi, my name is Bob. So it's only going to store the hi. So they put my name is Bob, and then name is Bob. This is unnecessary, but is Bob, and /0. Oh no, not the backslash. /0 /. Yeah, so Bob KLLO. Hi, my name is Bob. My name is Bob. Name is Bob. Is Bob. Okay. And oh yeah, the spaces, yeah, the spaces don't do anything. Pop KLL, okay, yeah, still nothing. So yeah, this was not good. So THH3IIUUEG, yeah, something. Yeah, /0. Yeah. TH, okay, it's THH3IIUUEG. Okay, yeah, it works. Yeah, this is not very good, but okay. Or just forget about the spaces, who cares? Like, just put one space, just don't put any spaces. Yeah. I'm like ultra complicating it, yeah. Simply just keep it like this. Make it refined and done, yeah. G++. So we got GHI, capital O, and then Jomo, GHI again, A B C D E F G H I. That'll make it GHI, Jomo, GHI, A B C D F G. Okay, yeah, it works. I didn't try numbers, but I think I already tried. Yeah. Okay. So yeah, we've got the refined S. That doesn't make sense, but okay. So yeah, we don't need these anymore. Then we'll say that. We'll say 4 int L is equal to 0, and also R is equal to S dot size minus 1. Okay. So when L crosses R, if it's the same, it doesn't matter. But if it crosses, then we want to stop. Or I think we should just say that L should be before R. Simple. L should be before R. That's it. Yeah. L should be less than R. If it's equal to or less than, greater than, then we don't want to. We don't want to continue. Yeah. And plus plus L and minus minus R. And then we'll say if SL is not equal to SR, we say that it's not a palindrome. We say STD no. And we just say return 0, like, for now. Just, and we'll say STD yes, if you actually didn't, like, if this if always became false. So it's always, like, the characters are always the same. Yeah. So compile and run. Okay. Pop, yes. OPO, yes. And OP, no. Okay. How about 1 2 3 RTYYT R321, and then HHGGHH 1 2 3 RTYYT R321. It's still a palindrome. What? No. What did I do wrong here? 1 2 3 1 2 3 RTY YTR YTR 321 HHHHGG. It works. Huh, okay. Maybe the capitalization didn't work. It does work, right? Because let's just print our refined string. So, refined S. Let's see what's the problem. So paste, run, take this again, paste it, and it didn't make it, right? It did work. Okay, something is wrong. HHGG 1 2 3 RRTYYYYYTTRR 1. Wait, I think I got it. Yeah. Maybe you could just call it refined S. Yeah, refined S, and not S but refined S. That's the problem. Not realloc, but refined S. Yeah. Right. This is most probably now correct. 0. Find S size minus 1. L less than R plus plus L minus minus R. Find SL. Find SR. Okay. Yeah. Now it will work. So let's get this, paste it. Yeah, finally it's a yes. If I say Q, I put it works. Good. So yeah, it's working. Good. And do you have a second one? No. Oh, okay. So what if I just copy this again and I say give me 5 beginner problems. Give me A5, give me 5 beginner programming problems. Yeah. It's supposed to be down here. Whoa, okay, yeah. Cool. Already done this. Okay. Factorial calculation. Write a program to calculate factorial. Okay. And it's the product of all positive integers less than or equal to n. Okay. But what's the size of n? Like range something. Yeah. Prime number check. Okay. Prime or not? Yeah. Write a program to generate the Fibonacci sequence, and
You can ask a follow-up question. Like you can ask that, like for the first problem,
yeah.
like copy that and then put it back there.
Yeah.
Give me constraints or input limits for it. Add input limits.
Yeah.
Something like that. No, you take one by one. Like if you ask for 5, it has got a limit, so it will not make it verbose for each of the 5 problems. Just ask one problem at a time.
Okay.
And also you can ask, please include the input constraints and all.
Okay. So like for this question below, can you give me a limit or range for the value for n? But okay. Okay, I think he just already knew that I'm going to put the factorial question. Give me the factorial question one. Okay, for the problem, the energy typically constrained by the limitation of data types. Okay, like see what, yeah, 0 to 12. Okay, 64 you can form 20. Okay, within the okay, cool. So I think I just use long and then go till 20. Okay, fine. Okay, so let's do that. Let's say chat factorial, yeah, that's how you do it, and dot cpp. Okay, I use stream, and that's it. Int main void, we'll say int n, and say
Return 0.
yeah. Okay, so you got the n, and now see if you have 0 you're going to print 1. So if you have 1 you want to run it 0 times. If you want to do it twice you need to run it once. Okay, yeah, so we can do it like this. You can say while minus n, this will run the loop n minus 1 times. Yeah, so if it's 0 it will just become -1 and then it's not going to fail. Okay, that's not good. Okay, so that's just not good. So we'll just say if n is less than or equal to 1, then we say system see out that facto factorial. Oh, there's no c. Yeah, c. Factorial of this number is 1 slash n and then return 0. Simple. If it's less than equal to 1. If it's 2, we want to repeat something n minus 1 times. And what do you want to repeat? So if I have 5, suppose, as n, so it will do 5, it will become 4, and then we check that it is working. So we're going to multiply 4, 3, 2, 1 and 0. So I think it's quite easy. We'll have our int factorial, I guess, factorial, and it's equal to 1 for now, I guess. And now we're going to say yeah, so we can say that factorial multiplied by n plus 1 should go into factorial again. Yeah, okay. And instead of having factorial as an int, we'll have it as long to support maximum. Let's say if n is greater than 20, they will say that too big to show, give the number you want to factorialize. Factorial, as if that's a word, less than or equal to 20. Done. Wow, okay, so then we return 0 again. Yeah, like we are calculated and we are saying too big to show. Okay, anyways, so factorial is equal to 1. So from 5 it will make it a 4, and then we checked it's a 4, so it's a non-zero value, so it is true. So it will do 4 plus 1, like multiplied, which is 5, and 1 times 5 is 5. Then n is 4, so 4 will get minus to 3, and then to stay at 3 it will be multiplied by 4, we get 20. Then 3 will become a 2, will be checked, and then we'll multiply it by 3 to get 60. Then now what? Yeah, so then the 2 becomes a 1, and it will be checked, and 2 will be multiplied, so that will be 120. Yeah, and then the 1 becomes a 0, it's going to fail, so it's going to do 120. Good. So this is how it works, and done. Let's say return, not return. We see std. No, not do this. We'll just simply copy this and paste it. So the factorial of n is something. That something is factorial. Yeah, done. Let's do this. First we clear this, because we're in a new problem now, sort of. So g++ minus o chat factorial, okay. So 0 is 1, 1, 2, what factorial of 0? Oh yeah, true. We have to store n somewhere else. Okay, yeah, okay. So, oh yeah, why? Oh yeah, it needs to be an int. So, okay. I can make it a short, but it doesn't make sense. we'll call it, I don't know, like temp for now. And now we'll say that temp is equal to n, and do instead temp minus minus and temp plus 1. Yeah, okay, and then print n. Okay, yeah, good, it works, I think. V plus plus, so yeah, so 0 1 2 3 4 5 6 7 8. Yeah, now just till 10 for now, and just 50 too big to show. Yeah, okay. And 20 also works, right? Yeah, 20 also works. Okay, so 20 and then multiply by 7, 49 plus, like 40 and 0 plus 40, correct? Yeah, multiplying by 8 to 32. Okay, yeah, so it's working. Yeah, okay, good, we got this done. Factorization calculation. Okay, prime number check. So for the prime or not question that you have given me, can you give me a range for the value n? Right, n, right? I think yes.
Not just n, like in just generalized, can you give some constraints for the input, or
Yeah.
the range of the inputs that will be given to the program, something like that?
Can give me constraints
Range for the input parameters, or range, something of that sort, like more generalized statement. Like,
yeah, can give me a range for the input for the problem, something.
let's see if he is able to pick up that second question he gave was that.
For the prime number check problem, the range will put and multiply data types again, like once again do it for the data types, like the range of the data types. You should work on that.
So did he pick up the same problem? Like,
yeah, he checked for the, he's doing for the prime number check problem.
so he did get the context. Like,
Yeah.
He knows what he gave.
Yeah, which is nice.
Okay.
So it's 1 approximately 2 billion.
Eat.
Huh?
Eat, not he, as you said yesterday.
Oh yeah, true. Yes. Okay. Okay. Typo? No, not typo. Okay. Range is 1 depending on the constraints. So for example, if the time sensitive. Okay, yeah. He's talking about if you have any questions, then like if you got a if you got any competition with this problem, then it will have smaller values, ranges. Okay, fine. So we'll say chat prime or not. Wow. Okay, I use stream and that's it. Into main void int n and cnn, and then we'll see what. Okay, I guess we have two ways of doing it. Yeah, no, just one way. Okay, yeah, you can just say for int d or something is equal to 2, and d should be less than what? Be less than half of n, so half of n, and plus plus d, right? So if I have 4, I only want to check till 1. 2 is not necessary because no, we are starting at 2, we're not doing 2, so I think we'll include it. Yeah, include. Okay, we say if n% d is equal to 0, you know it's not prime. So we say n is not prime and return 0. Or then we say std cout n is prime and /n and then return 0. Simple. Okay, t plus plus minus o chat yeah chat oh wait, what, chat prime or not. Yeah, okay. So one is a special case, but one is prime. Okay, to fix that, 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 and let's say 20. Okay, let's just check. One is a special case. Yeah, 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, yeah, it works. Good. That's it, done. Okay, that was easy. And Fibonacci sequence. Up to a given number n. Okay, so write a program to generate the Fibonacci sequence up to a given number n. Okay, so it's, I guess it's easy. We just need to just make the sequence, and then if the number is greater than n, then we want to stop. Okay, cool. That's easy, I guess. So file and chat. How do you spell it? Fibonacci. Okay. So F2. Okay. What was it? Yeah. So Fibonacci sequence, and we'll say hash include IO stream int main void int and it's like our limit, but okay, SACN. And now it's easy, we just say int first number, I guess, first num equals 0 and int second num equal 1. Okay, so now what? So we just say while true. Yeah, try get true. Yeah, so we first of all we just check if first num plus second num, if first num plus second num is greater than n, we break. Simple. So that's one thing. And then what else now? So 0 plus 1 should go, well, first num plus second num should go in our second, and then like the, okay, so if I have 0 and then 1, I need 1. So like this one thing. So this is our first num, second num here, and first num should be equal to our second num, Okay, I think we got it. So we can just say simply in sum, we can say sum is equal to first num plus second num. Then I say the first number should go, no, not so, first num should go in second num. The first one's value should go into second num. Right? Wait, so if I have 1 1 2 and to go to 1 2 and then 3, first num will stay first num, I guess. Okay, that doesn't make sense though. What if I go forward? So now we want 2 and we want 3 and then 5. So if I have 1 2 and 3, so first num should be gone, like, okay, so no, this is the first num. So first num plus second num is equal to sum. Sum should go in the second num. So second num is equal to sum, and second num value should go into the first num. So to say the first num is equal to second num now since we have calculated it. So basically if you have 1 and a 2, make the sum, and now we say first num is equal to second num, yeah, and then second num is equal to the sum, and we can just continue like that forever. Okay, until n like dies or something. I don't, not dies, but okay. So if I just add it and then check sum, yeah, greater than we break, otherwise we go forward. Good. Yeah, so we'll say g plus plus minus o chat Fibonacci sequence and chat Fibonacci sequence. Chat Fibonacci sequence. Okay, so go till 1 prints nothing. Okay, why? Okay, what? 3 plus 1 is 1. 1 is not greater than 1. Go forward. That's interesting. So, right, if I n equal 1, right, so if I run this 1 to get 1, and we say while true, 0 plus 1 is 1. Is 1 greater than 1? No. So go forward, but I'm not even printing anything. So yeah, cool. That's really sad. Okay. Say if the sum is inside, then we just print the sum. Simple. Space or a, I think I'm just gonna put a space, I guess, for now. Done. So g plus plus run 1 up. It's going to print a 1. Okay, cool. How about I say 2, 1 and 2? But yeah, before we do anything else, we need to do one more fix. Is that we need to also print our default 0 and 1. If it's a 0, then oh. So simply, first we're going to print 0, so 0 and 1 space. Okay, and I'm going to just go to n, and we're just going to say if n is 1, then we say std cout 0 1 1 slash n return 0, and If n is equal to 0, then we just print a 0. That's it. 0 session done. So you get the n. If n is 1, we print 0 1 1. If it's 0, just print 0. That's it. We get first now 0 and 1, sum, print 0 and 1, and maybe an extra one. No, because we need to keep it with the sum. Okay, yeah, okay. So I click. Oh wait. Yeah. So where is it? Yep. And so 0 and 0 and then 0 1. Why? Because I forgot to put a return 0. Okay. 0 will print 0, 1 will print 0 1 1, 2 will print 0 1 1 2, 3, 4, 5, 6, 7, 8, 9, not 0, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19 and 20. Who knows? Yeah, 25. Skip to 25. 21. Okay, yeah. Okay, it's working. Good. Now what? Fibonacci sequence, sum of digits. We already done this. Okay. Reverse a string. Okay. So we just need to swap places, I guess. Like O will become H and H will become O. And if it comes in the center, then we don't want to do anything. Okay. And if it crossed, then we don't want to do anything either. So we'll say new file, chat, reverse string.cpp, include IO stream, hash include string. I'm going to say int main void, and we're going to say std string s std cn s, and then got the s. Now we say for int I equal, not I, l is equal to 0 and r is equal to s dot size minus 1, l should be less than r, and plus plus r, l and minus r. Yeah, cool. So right, 0 size minus 1, increase l, decrease r. Okay, we're going to have a temporary char c temp, yes, temp, and we're going to say temp is equal to s of l. So now we can overwrite l. So now sl is equal to sr, and now sr is equal to temp, right? Right, because we're storing sl's like value. That means we can now erase sl's value by r, and now r will be replaced by sl. Yeah, good. And done. We flipped it, and that's it. So let me say s is s, like, and we're going to also have reversed s as s again, and then return a 0. Done. So g plus plus minus o, chat reverse string, not o, but okay. Okay, So if I have QWERTY again, it's going to be whatever. How about I say was, as we saw, if I have pop, it will stay pop, sort of. Then this will become this, right? 65432 1. Okay, yeah. And one last. Hi, my name. Oh wait, no. Bob, Job, Hob, Gob. It's going to become Bog, Bo, Hob, and Bob. Okay, yeah, it works. Yes. Now what? So that's it. Wow, like it's done already. Okay. Yeah, just give me 10 maybe. That will keep me busy, I guess. Okay, factor. I already done this. Okay, check Armstrong number. Check Palindrome number. Greatest common divisor. And simple calculator. Sum of primes. Okay, interesting. So it took arithmetic operations, loops, conditional, string manipulation, which are essential for okay. Yeah. So Armstrong number. Armstrong number is equal of the number of digits. What? Armstrong number is a number that is equal to the sum of its own digits raised to the power of the number of digits. Okay, that is something, I guess. That's fine. We can just put it in a string, get the size, get each guy, like make it to the power of number of digits, add them, make it an Armstrong number at the end. Reverse string, yeah, we already done that. So palindrome number, okay, I mean we already done that, but we'll do it again, I guess. Greatest common divisor, okay, I need to see this one. And simple calculator and some frames. Okay, so let's
Just a small interruption.
Yeah.
Like, are the programs thus far already optimized like to their max?
Yeah, I think so.
I guess you know better.
I think so, yes. Where is it? Yeah, here, right? Factorial calculation, yeah, and yeah, same n by 2. Yes, this is already done, and this is also, yeah.
Oh,
So
there is no off one or something.
no, I don't think so. No. So chat. Now what? Yeah, Armstrong. I think I spelled strong wrong. Right? No. Okay. Okay. Armstrong.cpp. Wow, we got a lot of files. Yeah. And done. Okay. So include IO stream, and we need to see math library for the power function pow. Okay. Let's say int name void, then we got int n. Yeah. Okay, so we got Armstrong number. And why am I having an int? I want a string. So give me string. Yeah, good. Okay. And okay. So let's say in total, I guess, is equal to 0, and say for auto C or D for digit in n, and once we get our digit, take the digit And since ASCII type starts with 0, like we learned yesterday, we can say total plus equal power of something, and that something is that digit minus like ASCII value of 0. So that will give us that. So the ASCII value of 0 minus ASCII value of 0 is 0, 1 left, 1, 2 left. Yeah, okay. So that's one expression thing, and we to raise it to the power of n size, because that's what is an Armstrong number. Done. Good. And now what? So auto d and total, yeah, d of 0, yeah, okay. So we do that, and then we say if total is equal to the I to a, like, no, I think it's a to I now, because now we need a string. Yeah, we need a string, and if it's equal to that, right, and what happened? String to con, okay, what, really? Yeah, so to number, to int or something, to number, maybe it's in std or something. So let's see, to string, right, to integer, yeah, good. We need n, right? Will this work? No, because oh, so you're saying I need to remove this std? I don't know. It saying the parameters will not match, and now it's saying, okay, so it's this. So what do you really want inside this? Okay, this is not good. You know what? I'm not going to confuse myself. I'm just going to say int n, and then we'll make a string called stir n, and it is equal to I to a. Oh no, not I to a. We say std is to string, not to integer, to string. Wait, what did I use first for the sum of digits? This. Just copy you for 1 minute, and Armstrong, yeah. What is the problem? Okay, wait, do I need algorithm or something? What is it? No. Okay, something is really wrong. Int and stir and wait, what if I copy this? Where's it gone? Compare it with this. Get the n. It still doesn't want to. Oh, I see. I need a string library. Yeah. Easy. Okay. Okay, good. Yeah. So stir and so I can use that two integer file. Who cares? And not n, stir n, and not n again. There's no dot size function inside n in the int, so stir n, yeah. So total, we get that, and then we will simply just say if total is equal to n, we say that n is an Armstrong number. Wow, okay. Otherwise, we say it's not an Armstrong number. It is not an Armstrong number? Yeah, okay. Okay, that was easy. So I stream, yeah, okay. This, get the n, put inside a string. So to each character of the string, get the digit, get its value, and done. Okay, that's cool. Right, and that's how it is. Armstrong number, yeah. Enter user, some of the digits is each raised to the power of number of digits. Done. Okay, so now what? Just run. Okay, so chat Armstrong, chat Armstrong / chat Armstrong. So 159 tells number now. Armstrong number. Cubes are those digits. So cubes. Interesting. Okay. I see why they're like sort of since they're only 5 numbers, I think. That's it? Okay, well. It's 1634? Yes, it is. Find the sum of the 4 power for each digit. Now, sum turns out to be this. Okay, yeah. Okay, so number of digits, yeah. So let's try these numbers. Yeah, 1634 as well. And now let's do it. So let's run it. 153 370 371 407 and 1634 and 8. And 8 is an Armstrong number. Oh yeah, true. But no, it's just the cubes of its digits. And this guy is saying that sums to the 4th power. Really? Something is clashing. Okay. Okay, I think I got it, yeah. So, maybe, just maybe, but to combine both things together. Like, no one really knows 4-digit Armstrong numbers, so we'll just say, we get our n and we say, if n is a single digit number like this, and if it's less than 10, then we want to do something. Then we want to say, if it's not less than 10, go forward, like wherever it's there. And if it's less than 10, if it's 1, if n is equal to 1, then we say yes. And we say the yes thing. Otherwise, we say that it's not. Put the return 0 here because we need to return 0 in both cases. So, done. So yeah, where's it gone? Yeah, now 8 is not, okay, and 4 is not, and 3 is not, and 0 is not, and 1 is, okay, and this, yeah, okay, you get it. 407 for now. Okay, done. So that's how it is. Good. ChatGPT. Okay, yeah. So Armstrong number complete. Check for palindrome number. I mean, I can just use my palindrome checker again, whatever that was. Where is it? Oh yeah, he gave me here. So yeah, I can just use the same thing. No need to do it again. Greatest common divisor. Okay. Write a program to find the greatest common divisor of two positive integers entered by the user using the Euclidean algorithm. What's this? Well, it's gonna show us the answer. Oh no. What if I go to Wikipedia? Let's see what it's trying to say. Some change the larger number by its difference with the small number. One. And as this and this, so number is also 105 and 147. Larger two numbers. Repeating this process successfully gives smaller numbers until two numbers become equal. Therefore, they are the GCD of the original two numbers. Erasing the steps or using the extended one. The original two original numbers. Okay, wow. That is interesting. Well, okay. Okay, so what is it? So the greatest common divisor of two numbers does not change if the larger number is replaced by its difference with the small number. So you're saying if I have sum A and B, GCD of these people, it is equal to, yeah, this, like literally it's just, yeah, literally just giving us the answer. So B and A minus B. Cool. So B minus A. Okay, so because A, so it's a greater number, becomes A minus B, right? So wait, is that correct? A and B does not change if the larger number, say A, is replaced by the difference with the small number. Its difference with the small number. So it will be AB, GCD of A and B is equal to the GCD of A minus B, B. And which one is bigger, you can take that. And you're saying that you do that until the numbers are equal, thus giving us the answer. But how do I know if the GCD is this or not? And by reversing the steps, we can bring it back, I guess. This is very interesting. Instead of replacing the line, stops when, okay. Can take many subtraction steps to find the GCD and gain one of the numbers, such bigger than the other. A more efficient version of the green chart could see steps. Instead, replacing the larger of the two numbers by its remainder when divided by the small number of the two. With this version, the algorithm stops when reaching a zero remainder. With this improvement, if I more simplify times the one. Okay. Okay, but that doesn't really help me finding the GCD. How about I can just simply do this? Yeah, it's easy, I think, for me at least. What we can do, we can take the prime factorization of each number and then try to see which ones are common, like which numbers are common to each other. And that is the answer, right? If I have, say, 5 and no, not 5, let's say 64 and 1024, no, not 1024, maybe, yeah, so if I have 64 is equal to 2 multiplied by 2 multiplied by 2, so that's 8 divided by 2 multiplied by 2, 5 6, 7, 8, right? We have 8 2's, right? Right, so we have basically have 2 multiplied by 2. And that repeats this many times. Yeah, good. So 6 2's? Yeah, 6 2's, yes, correct. 6 2's is equal to 64. And how about for 32 multiplied by 3, which is 96? Yeah. 96 will have 2 multiplied by, now since it is 96 divided by 2 is equal to 40, right? 40 plus 8, 48. 2 times 48, 48 is 2 multiplied by okay, wait, what if I do it on, not bad, yay. Wait, where is it? Yeah, so 64 is equal to 2 multiplied by 2, right? And 96 is equal to 2, so that's 48. Another 2, that's 48, right? Yeah, 48. 24, 12, and then 6. I think this is it, I think. So 2, 4, 8, 16, 32. 32 multiplied by 3 is 96. Okay, so if I got this, we can see that these ones match. Yeah, so we're gonna have a greatest, okay, divisor of, greatest common divisor of 32. GCD of 96 and 64, please. What? Greatest common divisor, sorry, yeah. Of 96 and 64. 32, correct, yeah, so it worked, yeah. What's this? Interesting. 96 by 64, 132. I don't know how this works. Okay. Okay, cool. So let's do this. So I have to take the prime factorization of each number and then find the numbers that are the same. Okay, that's a bit difficult, but okay. We can try. File. Chat. GCD. Okay. So say hash include IO stream. That's what it, yeah, for now at least. No, I think we need a vector. Yeah, we need a vector. Yeah. Boom. Okay. Boom. How are we going to do this? Now let's see. So we got int a and we got int b. We get those two numbers, a and b. And then we say SCD vector of int called prime factors a. I'll say a prime factors to prime factor of a. Yeah, literally. B and B. Vector of int called prime factors with some integer a or integer n, let's say. Okay, so now what? Because of B. So first maybe we could do it like maybe we can make another function that also returns a SG vector of int called primes below n. We'll say in n. And this time what we'll do is that we'll use the sieve of Aristophanes. I don't know how to pronounce it, but basically we're going to write all the numbers, if I can, not all, but up to a certain range, this time till n, and one will become a star for whatever reason. Well, it's because it's special. Then we go to 2, and 2 is prime, so you put prime, and then you make every single one that is a multiple of that number composite. Right, like so. Done. Now 2 is done. Now we go to 3. 3, since it has no token or anything on it, we make it prime. Let's type in space. Okay. Now we make the multiples of 3 composite. 18 and done. Okay. Now 4 is already marked, so we go to 5 and you make it prime, and then soon this will become C. This is also C, and this is also C, and then 7, 14, and then now P, and 11, no 22, then yeah. So if you go if you go past the half, every other number, like every single number that's not marked, is prime. Done. And then you get our list. Simple. Cool. And that's how you get primes below n. Cool. So let's do that. Yeah. Cool. So yeah, we'll just not include one. That's like the easiest way. So how am I going to do this? So we have to keep track if it's prime or composite. So let's do it. Yeah. So we'll say std vector of int called, first of all, primes below n, or primes, and we're going to also have, oh yeah, I mean, I think it's much more simpler to do it like this. We got our primes, right? Thing. So we can make 2. Okay, good. So no, wait, doesn't. Maybe I was thinking that what we can do is we can set primes first equal to just 2, and then you say 4 in num is equal to 3, maybe even 4 or something. 5, 6, 7. How long will it go? So okay, let me just say now is equal to 3 or 4, let's say, and we'll put 2 and 3 inside, and we'll say num is less than n. Right? Why am I doing primes below n? So that when I get those numbers, I can use those primes, and we can use it against n. Like we can use it to see if I can divide n by any of these primes, because any primes that are bigger than n won't work. So yeah, and I guess it also include n, because if n is prime, then we want to like it's going to first check n and then see that, oh, it works. So it work from backwards, like no, from the beginning to the end, because okay, yeah, okay, so for now we'll get the primes below n or equal to n. Okay, anyways, num is equal to 4, num is less than equal to n, and plus plus num, and we're just going to say and we can see if a number is prime by looking at the numbers before, right? And if it's divisible by a composite number, it will be divisible by a prime number. That's because composite numbers are made out of prime numbers. So what we can do is we can say for auto p in primes, right? We're going to say if num percent p is equal to 0, so it's divisible by a number. It could be part of a composite or not, doesn't matter. It is still divisible by a prime number. If it is, then we know it is a composite number, and we don't want to put that number at all inside. Cool. So wait, can I just apply the same logic for the prime factors? But no, I have to every time search again and again, is it divisible to divisible. So if I just make the primes list and then use it again, like for n, it'll be good. So if it's divisible by some prime number, then it doesn't matter which number. Then you know that it is composite and we don't want to add it. So we break and we say that don't include this number. Somehow we'll say don't include number. Okay. And then we say and if it went out and it found that there was no prime number that was divisible by this, it itself is a prime number, and we put that in primes. We say primes dot push back this num. Okay. If it is not composite, composite. Oh, okay. Composite. Okay, yeah. Okay. We say not composite, then we put it inside primes. That's it. So let's make a bool as well called composite, and we say composite is equal to true. Oh no, it's false, sorry. False And if you found it's divisible by some prime number, then we say composite is true, and done. Right, so we got the primes 2 and 3 for whatever reason. We start at 4, and we say num is less than or equal to n plus plus num, and we say composite is false. Then we go to the list of primes and we say if num percent that prime number, so dividing it gives you 0, gives remainder of 0, we know it is composite. But if it never made composite true, it is still false, and that means that it is a prime number, and we put it inside our primes, and it will come in later use for different numbers. That will now include our newly inserted prime number. Done. From that we can get to primes below n. And after that, oh yeah, first of all we need to return it, so let's return that first. Try out return primes. After that we say the vector of int called prime factors now, and it's going to be equal to primes below n for n. Okay, that's one thing. Now we got the prime factors, and what we will do now is we will go and divide n continuously. Okay, cool. So we say while n is not equal to 1. If it's not equal to 1, go in. Yeah, okay. What do? We say, wait, why am I doing it like this? Can't I just make, but no, I don't know the list of primes, right? Okay, so yeah, so we'll say n is not equal to 1, then we say for auto p in primes, we say if n divided by some prime number gives you a remainder of 0, then we do n slash equal p, and then you break. Otherwise we know that it is done, like not prime factors, just primes, just leave it primes, who cares. Primes, yeah. So if it's divisible by some prime number, then we can divide it by a prime number. True. Then after that, look in the list again and just check if it's a 1 first, and then divide it again. Try to divide it, and soon when we get, so we need to include n. So when we get our n, then we can do it. So if I do 1% p, 1% p will give me 1. So no, actually we're just gonna check 1 before actually getting 1, so that's fine. Okay. And what if we got number is a prime number? Then it's going to check, it's not going to divide by any number except that number which we're including by this. Thus it's going to bring that in our prime factors as well. So yeah, we'll also make now we'll actually insert it. So we'll say prime factors, okay, and it will be equal to nothing. And once you get, when it's divided by p, we'll just say that prime factors dot pushback p. Right, prime factors get a p because it's part of it. And if it's again divisible by 2, it will divide it by 2. And go do it again and again, and then done. That's where it reaches 1. Okay, done. and then we say return prime factors, and it will be divisible, like any number will be divisible by something, right? But what if we got 1? I think that's an edge case that we need to handle up here. Like if any one of the numbers is 1, then the greatest common divisor is 1, because if I have 1 and 5, 5 is not the greatest common divisor, because 1 by 5 is not going to work. So we can just say if A is equal to 1, or if B is equal to 1, then we'd say that STDCL, the greatest common divisor of A and B is 1. Yeah, simple. Cool. And it's return 0 then. Okay. But what if I do like this? What if there's no common divisors, but there's always 1? Okay, yeah, so when will it not work? So what if I have 9 and 4? They're not primes, but they don't have any common divisors. So it's except one, yeah. So yeah, it's sort of difficult then. But I think that's easy, that we can just check if the list of common factors is nothing, then we get to just print 1. Okay, cool. So yeah, so we get the prime factors of each number, and then we're going to say match them together. Yeah, cool. But how am I going to do that? Like maybe I can just count the number of 2s, 3s, and all that, and then which one, then we can go to each one of them, find 2 and 2, add these things. Well, okay. Or maybe we can do it like this. We can say for auto PFA, prime factors of A, in A prime factors, we can say try to find PFA in B prime factors. If you found it, delete both of them and multiply it to our thing here. So and GCD equal 1. So if none of them are common, then it's going to stay 1. And now we're going to say, so I need to look at the find function. Where is it? Yeah, okay. I'm going to say std find and find. Because it will be sorted, maybe. Right, so if you didn't find it, then we had to just say delete to that one. But deletion takes some time, right? So deletion will take some time to work out, so it's not that great. How am I going to actually do this? So if I get all the prime factor and then try to pair them, first of all, that'll take a lot of time, I guess. Maybe let's see. So if I have a 2, right? I mean, I just count and then, yeah, I think we just need to count them and then you're good to go. So, here. So how am I going to do it though? Maybe I need a vector here, maybe. Maybe I can just return a map. Just a frequency map. Right? That seems easy, maybe. Yeah. So, and then we can go to the first element of the first prime factor of A. Look how much we have. Look the same in that one. And subtract them. And we'll see that we have that many 2's that can be paired. And then that's it, done. Okay. The same for 3 and then 5 and any other factors if there is any. So, okay, that works. So, we to include the map. So, let's get a map. Yeah. And, whoa. I don't know what was that. Okay. Okay, so take this and make it a map. Int to an int. That's it. And yeah, I mean, it doesn't work, so let's make it work, I guess. So yellow here, and then, yeah, that's about it. And, yeah, this guy here. Yeah, you can do pushback, I know. Prime factors P plus plus. So go to the Pth key and just increase its frequency and done. Simple as that. Cool. That will go, it will come here, we get our maps, and then we're good to go. So, we say PFA, right? And then we say, so I think the dot add function gives you an error, so that's one thing. So int PFA count, and we could have a whoa, what was that? Okay, PFB count, yeah. So we say PFA count is equal to PFA, since it's a pair now, we can take the second number and done. And then we say we try something, and that something is B prime factors at PFA. What? Map. Do you want a pair? What? Wait, something is wrong. Let's go to the dot add function of map. std map add. That's how you do it, yeah. Add, where's the add? Yeah. Out of range exception, but what do I have to give? Add this, right? So int. I'm giving you an int. Give the first guy here. So try this. No way. Map. What? and with int plus an int. What is the argument type? If our object type is what? So you want the pair? No, I'm giving the pair. That's the problem. Okay. Dot first, yeah. Okay, give it PFA dot first. Okay, so try it. If you catch a out of range exception, we say that PFB count is equal to 0. And this we do, and then we say PFB count is PFB count is equal to this. So if you run into an error while doing this, then PFB count is 0. Otherwise, whatever value we get, we put it in PFB count. Okay. And I think that's how it works. So we'll just see that later. So PFA count is equal to the count of the current PFA. And PFB count is, we're going to try putting the value at PFA dot first, so whatever prime factor of A that we're actually having. And if it puts an out of range error, we say PFB count is equal to 0. Otherwise, we just put whatever values in PFB count. Okay. After that, we get our PFB count and we say that how much displacement do we have? Like how much leftovers are there? So how do we do that? So I'm going to get the CMath library for the absolute function. I think so it will work. So let's see. So GCD multiplied, yeah. I think it will work, right? Because it's not that big. So GSD multiplied times equal something. What is that something? Power of something. And that is PFA to the power of the number of similar elements. Okay. So wait, so what if I make this a bit simpler? I'll say that the absolute of PFA minus PFA count minus PFB count is equal to the number of leftovers, right? Now these leftovers can be used to figure out how many elements are getting paired. So how do I do that? So what if I have the smaller number and suppose I subtract it with the leftovers, right? And that will be negative. So we're going to add the leftovers and it's going to bring us to the bigger number. But it doesn't help us, right? You know what? I'll just do this. Find the smaller of the two and use that. Simple. We'll say if PFA count is less than PFB count, then we say GCD times equal.
Small. How much more time is left? Or we can have food? It will take more time?
Yeah.
Roughly?
Yeah.
How much time?
A lot?
A lot. Like this is the last problem?
Yeah, no. It's like I had to put this and this.
So maybe you can do the other ones after the break. The remaining ones. Remaining are 2, right?
Yeah.
And how much time for this one?
10-15 minutes maybe, I don't know. It's a bit difficult.
Okay. Yeah. You want to take a break or you want to continue? You want to get done with this and then,
I think we'll get a break and then we'll do it.
or you want to like get this done completely, finish this one?
No. We'll take a break for now.
Okay. Okay.
Okay, so we'll see you after the break. Hi everyone, welcome back from the break. So what were we doing? So we're doing this problem, GCD problem. So my idea was that we take the prime factorization of both of the numbers and then we'll try to match them. Like both of the numbers prime factors will be paired and we'll know that what is it is GCD from that. So just to check if I'm correct or wrong, so to find the prime factors of a number, I need to first find the primes that are below n, which is quite easy. You can just get 2 and 3. You go to the composite, like there's a bool called composite, and num equal 4. Num should be less than equal to n because n could be prime, and we need to include that. And plus num, and if composite is false, is going to be false, and then we'll go to the current primes that we have so far, and we say if num %p, so if it's divisible by a prime number, then we say composite is true and we break. Otherwise it just goes through all the primes and it sees that it is not divisible by any of the primes, and since primes are the building blocks of all numbers, that means that that number itself is a prime number, and we put that here if composite equal true was not done. After that we get all the primes below n. That's sort of incorrect, but it also including n, but okay. After that, when we get those primes, what we can do, we can go to our n, now our actual n, and we'll just go through each of the prime numbers, and from 2 to whatever, like less than n prime number, and we'll just say if n%p is equal to 0, it is 0 by some prime number that is prime factor. And then we go to this frequency map thing where we go to the pth key and then we just say plus of that, and then we just divide it. So we can do it, we can further calculate, and when we reach 1, that means that we've got all of the prime factors, and 1 is not a prime number, so it will not be there, and then we get all the prime factors of n. After that, since it is a map, we are getting the count of a when getting one of the factors of a, or one of the factors of a, and getting the count of that, putting it in here, and then I'm going to try to get if the prime factor of a, which is currently pfa, is set to pfb count, like is there in p prime factors, then it will not throw an out of range exception and to set it to pfg count. Otherwise it will set it to 0, and we do pfa. If pfa count is less than pfb count, then we know that we need to count the number of pfa, like whatever the count of pfa is, which is pfa dot second. So I mean, we don't need this then. Okay, so we can do that, I guess, then. So pfa count, well, no, not really. So we can remove this. We also need the count, so that's one thing. So we got pfa dot second here. So if pfa dot second is less than pfb count, which is just this, if it works, then we say that we to multiply pfa second dot second pfa count times, this is the count, so we want the number. What is the number? The first, so we need the power function, so power, so you get this, the factor, two few arguments, okay, and pfa dot second. So basically we have the factor first, and we're using it to the power of number of that factor. But if pf count is greater, then we go and yeah, so we try to do, we already tried. So pfb count to the power of pfb, since we noticed there, dot second, but we don't have a pfb. So I have to take p prime factors and oh, no wait, okay, wait, yeah, the count should be here like so, and then we can take this thing, right, and keep it here. Now since you notice there, we can just do pfa dot first, take that number frequency, or just pfa first, yeah, pfa first, not the frequency of that, because we cut the frequency. So yeah, good, yeah, correct. So right, this, wait, okay, let's see. What if I just don't use a map? Maybe I do that find thing, I guess, rather than having this. Maybe, I don't know, we try, but no, we could just stick to this. So we get prime number and its frequency. So we will go to each of the prime factors in A, and we will, since we know what it is, we try to get the count of that factor in B. If it's not there, then it's 0. Okay, and if there is, that will set to BFP count, yeah, or yeah, okay, or maybe I could try this. We could have, what is this, add return an int. Okay, so I want the pair. I can't get the pair though, right? I can't do that. Okay, yeah, so get the prime factors, search the prime factor in here. If you don't find it, then you get an out of range exception. That will mean that there is no ones, like there's nothing to pair with, and then otherwise then you will have some value count, right? And then we go to the count of a factor, right? Because we want a smaller number. So smaller number, this one, if a has the smaller one, that we need to take the a and do it. Otherwise, if b is the bigger one, a smaller one, sorry, then we have to say p dot first, because that is the factor, and instead have pfb count to the power of pfb count, because pfb count has lesser one. That's all. Okay, and we multiply that to GCD, yeah, and done. And that's how you get the GCD. And let's say just go get this dude and paste it. Divisor of A and B is something. That something is GCD. Yes, pretty big process. True, whatever that was. Okay, boom. Okay, let's see how it works. Okay, chat GCD, yeah, chat GCD. Really? GPT GCD, really? Okay, prime factors and prime 0 1, yeah. Okay, so we got to get those two. Other than that, we are fine. boom and boom. Okay, boom, and then these two and put it here. Done. Good. Where is it? Yeah. Okay. And now try it works. Dot slash check GCD, and let's try 96 and 64. 32. Wow, it worked. Okay. Yeah. 2 and 5 is 1. Yeah, true. Like, yeah. How about 48 and I don't know, 90? 6, right? Because divided by 6 and 48 as well. So 12, no. 30, 20, no, not 20. 20 doesn't work. 15, yes, 15, but then 48. Yeah, so yeah, I think 6 is the answer. 6, 12, 18, 18, 18. 18, and then 24 maybe. 24 doesn't work. Yeah, I think 48 and 90 GCD of 90 and 48. 1 2 3 6. 6 is 1 2 3 6, and 6 is the largest. You can see 8 is the answer. 6 is the answer. Wow, it's actually working. Okay, yeah, using the same thing that I'm doing, getting prime factorization and combining them together. Okay, let's try a different one, like 100 and number that will not fit at all. So 3 is 1. Yeah, because 100 is not divisible by 3. And 178. Oh no, it's 2. Okay, yeah. So yeah, that's how you do it. Wow, I did it. Good. Thought it was be much more difficult, but it just worked. Okay.
So like, how do you test it? Like, is it?
I just tried
Is it
random.
exhaustively correct? Like, can you ensure what are the limits of the program? So
Well,
boundaries that you have.
huh?
Like, what are the boundaries of the program? Like, can it work for any number?
Any number? Oh, that is could be in an int. Yeah. Becoming an int
That
obviously.
should fit inside that.
Yeah, int. What if I just give it int max or something? First of all, what is int max? What is the max limit of int this? So if I just take this number and I sort of round it to the nearest highest digit, I don't know, that's the thing. So take this, make this a 0. Oh wait, what? Okay, I thought, okay. So 1 2 3, okay, wait, what? 7, right? So we got 1 2 3 4 5 6 7 8 9 10. Okay, good, clear. 1, wait, no, first run it. Okay, 1 3 4 5 6 7 8 9. And how about 7 8 9 for whatever reason? What? They just crash? What? What just happened? What just happened? Okay. Did I just overshot it or something? See, there are 1 2 3 4 5 6 7 8 9. You know what? I'll just take this and put it in Notepad. See what I get. How much did you select? 10. Okay, interesting. 1 2 3 4 5 6 7 8 9 10. Yeah. How about 1 Still nothing. Baba, I think there's a problem. If I put very big numbers, it's not working. For whatever reason.
Yeah, that is the reason. What is like how big numbers?
I took the int max, and since they are 10 digits, right? They are 10 digits. Yeah. So I just took those and made 1 0 0 0 0 0 0 0 0 0. That's it.
So you are trying the GCD problem, is it?
Yeah.
And you should have two numbers as input.
Yes.
So which two numbers you have taken?
Just
The int max and
not int max, no. Like 1 with 9 zeros. Wait. Maybe it's taking some time, maybe.
yeah.
But why is it still
You
taking
calculate
input?
sorry.
Now why is it taking input again? Like it's still like type something, sort of indication.
No, it doesn't. It seems that it's taking input. It may not be taking. If it is working in infinitely,
Yeah.
so it will not appear that it is taking input or it is just working. So just kill it and just see in GDP what is happening.
I'll take this. Where is it gone? Yeah. Minus G for debug mode. Debug mode. Okay. GDP and what? Chat GCD. Now run. Not run. Vmain. Now run. And okay, yeah. So right? Did I type it correctly? 1 and 6 7 8 9. So it is just, oh wait, quit. Okay, if I run this, run, no, vmain run, and this, oh no, step in.
Is it still taking input?
No, it is going here and it's like done.
I just be back.
Yeah. So vmain run 1 2 3 4 5 6 7 8 9 7 8 9. Now step in prime factors. What? Okay, just made this. Okay. Oh wait, step inside this. Now work. Okay. Maybe this is taking a lot of time to, like, it will take a lot of lots of time. Where am I? Wow, I mean there's a lot of prime numbers, really. Still like 100, like 10 to the 9th power. So yeah, this is not good. I mean, yeah, it's going to take us it's going to take us eternity to get back. That's the thing. Okay. So yeah, I mean, I can't do this big. Otherwise, going steps of one will completely. Okay, yeah. So now what? So maybe I just take 5 something, and then I add 2 every time. I don't know if that helps. Reduce it by half, but that's practically nothing for 10 to the 9th power. So yeah, Cool. So that's it. But yeah, we can only go till half, right? Because no, not really, because there will be prime numbers there as well. So like we have to do the sieve again, and the half of the spectrum, like half of the chain of digits, now numbers. So if I go from 1 to 10 to the 9, it's like for the 1 to the halfway point, it's not very predictable. But for the other half, so if there's prime numbers, it means that they're not marked by a C or a P. So that is a prime number, but I cannot mark it because I don't have 10 to the ninth power, like spaces to show that it is prime or composite. So yeah, this is not going to work that easily. Maybe I should ChatGPT because GCD is a bit, well, difficult. uh, difficult. So um for the GCD problem that you have give, can you tell me the range of the two numbers that the program will do the GCD of? If that makes sense. Whoa, okay. Like, I know and you can use 32-bit integers and go to this extremely big value. What is the most practical way, right? I can't really. So, like, um, yeah, I mean, it just goes this big, but okay. Wow, now since you have told me this, GCD of negative numbers? The greatest common divisor of two units is the same as the GCD of their absolute values. Therefore, the function can just replace negative integer with the negatives, which are positive. Okay, yeah, I mean, fine. I mean, you can have one and negative one, but no, it needs to be both negative, then it will work. But it's negative 1 prime? Yes, of course, because it has negative 1 and 1 as its factors. So negative 1 is a prime number. Okay, cool. So as negative 3? No, because it has 1, 3 and negative 3. So 3 does not work. So there's one negative prime number, which is negative 1. Okay, yeah, anyways. So yeah, I can't work that big because my program can't step in steps of 10 to the power of 4.5. That's the thing, because we are halving it, that's why. Cool. Okay, so let's see if my new version works, because obviously it won't work for big values. So what do I want here? So uh, mm, this, like 96 and 40, 64, yeah. 32 it works. 45, 47 it's 1 because 47 is a prime number, it won't work. 49 and say 7, it's just, yeah, true. 15 and 80, and that will give us 5, and then 15 and then 90 will give us 15, yes. And 100 and an 8 will give you 4, and then 3 and then 3 will give you 3. Yeah. Okay, cool. It works, sort of. I mean, it won't work for all the ranges of all the numbers of an int, but yeah, I mean, I can't do anything to that, honestly. Okay, GCD, yeah, now what? Simple calculator. Okay. Write a program to implement a simple calculator that can perform addition, subtraction, multiplication, and division based on user input. Okay, so let's make it as friendly and formal at the same time. Okay, I think I got a whoa. By double clicking, we can get new untitled things. Wow, I never knew that. Okay, so let's make a chat simple calc. Yeah, I can't write calculator. I can calculator. Yeah, it will fail. Yeah, true. Okay, hashing P3. Okay, hash include IO stream. Hash include nothing. Yeah, honestly, nothing. Main void. Okay, now what? So we'll say I'm gonna define four things. Const int add is equal to 1, and sub and null and div. Yeah, sub null and div. Dick, not div. Okay, cool. Now what? So you want int first num like first num int second actually I don't want an int. I think I'll choose floats just for division. And so yeah, and we need int operation. Done. Okay, so cool. So let's make a print function. So the void print, and it will just print a default template thing. And oh wait, what? I forgot. Yeah, std cout add two numbers, and that will be 1. Wait. No, okay, yeah, I'm sorry. Yeah, like press 1 to do this. And wait. To subtract. Oh wait. Subtract 2 numbers. Copy this, paste, paste, paste. 3, 4, 5. Say wait. Or maybe I just keep it 0. Why not? Right? Because 0 is not used. So let's now subtract 2 numbers. Multiply and also divide. Okay, cool. And then we'll say please enter option and get the option. Well, that's not what the print function does. Okay, cool. Let's say do while something. I don't know. Excuse me. Yep. Now what? So first num, second num, operation, and option. Not operation. We just want actually option. You know. So while option is not 5 or 0, sorry, right? If it's 0, 0 it's not equal to 0, that is false, so it will break, and then the end. Okay, let's go. We'll say STD CL by, and then return 0. Done. Yeah, it's that simple. Do what? So we get Mr. Option. Yeah, okay, and we don't want this. We just say true. So CSDC in the option. Now we say switch case. What option? And do you want to add? And do you want to subtract? And then do you want to multiply? Do you want to divide? Not div. Or do you want to quit? Yeah, I don't have that, so 0. And we just say, if I say break, it's gonna only break up on the switch. So we can say done equal true. And then we say, if done, then break. What is done? Where is done? Okay. Bool. Bool. Done equal false. Cool. Done. Okay. Add sub. What's up? Oh, okay. 2, 3, 4. Thank you, switch case. Okay. If you want to add, okay. So you got the option, obviously. Wait. We're just going to say first print. So print your option. Get the option. We're going to say simply enter the two numbers. Let me see. Number 1 and number 2. Then we're going to say after CL, CN. First num, and then the second num. Okay. Option, now add. Now we got, so we say first num plus second num is equal to first num plus second num. Wow. Okay. Crazy. Oof. Okay. Right? Yeah. Okay. We're just gonna put just 2 slashes and closing, like hugging the thing, and we can remove the slash from here. Num and second num, first num, all that done. Okay, quite easy. And then say first num minus this is equal to minus second num multiplied. And there's a way of doing division sign. I don't know how. This is not backslash, slash. Yeah. Alright, so let me just see how to type division symbol. Microsoft Windows. This division sign is produced with Alt 0247. 206 with no 0 on the number pad. All I do is doing Alt GR. I don't know what GR is, so I guess yeah, Alt. So let me just see if it works. Oh God, why? Alt 0247. I have found it. Yes, yes. Good. Now copy this extremely important thing and we digitally paste it and done. I don't think it will work, but who cares? It's not going to be able to print or something. I don't know. And yeah, that's it. Hallelujah. Okay, whatever. Yeah, remove this. We don't want this. Here, b plus minus all simple calculator. So chat simple calc for chat simple calc. Print f no. Oh no. I wanted to print. Oh wait. Control H. Find print this with print menu. Good. Complete. Oh, okay. Copy this, paste it up here and done. No, not really. We'll just say const int called quit and it's equal to 0. Yeah. And instead of putting 0 here, we'll put quit. Cool. And now let's do it. Yeah. G++ / chat simple calc. Add two numbers, subtract two numbers, multiply two numbers, divide. Yeah, so if I just write 7, enter two numbers. Okay, 1 and 3. Poof. Okay. Okay. I try to put like a little Easter egg somewhere. Like, if you try 314, then you get like, then you just like put pi or something. I don't know. Add two numbers. I want to add two numbers, please. 12 and 13. 12 plus 13 equal 25. Yay. Okay. Okay. How about 45? Oh no. 2, 45, and 90. Minus 45. What? Not by. Wait, don't go. What if I add two numbers? Minus 90 and 100. That gives you 10. Okay. Oh no, why am I pressing enter? Okay. So 3, 45, and say negative 89. Negative 4005. I'll just go with it. Who cares? 4, 56, and 6. Why not? Right? Not 6. I should like 54. Okay, yeah. 6. 9.3. Oh yeah, the division sign. Yay! We got the first division sign in the universe. Okay, just kidding. And it will say 0. It will say these and say pi. Okay, this is not cool. This is not cool. Okay. So I guess I need to just remove this. Yeah, because before quitting it's asking us two numbers. That's like, okay. So we just paste this, I guess. Not case quit, but we just say if option equals 0 equals 0, then we say done equal true. Or like not even done equal true, we can just say break. Where's my if? Yeah. Break. Or break. Okay. And no need of done anymore. Show. Why are you there? Yeah, shoot. Right, if option is equal to 0, it wants to quit, so just quit, right? Just quit. Otherwise, do this and you're good to go. Yeah. Right, G++. Yeah, okay, so 1, 2, 3, and 2699 or something. Okay. And oh god. 2 and 90 and minus 80, 170. Guys, did it faster than your computer. Okay, just kidding. 56 and say negative 00999. Okay, I'll just believe it's the correct answer. Like, I don't know. I think it is because it is just 56 multiplied by 1,000 minus 56. Simple. So adding 56, we do get, yeah, 56. Yeah, okay, we're correct. Okay. Mr. 4, 35 and 7, 57. I don't know. Yeah, I don't know if that's correct. Okay. We'll say 0 and it will say bye. Good. So it worked. Yay. Okay. Sum of primes. What's this? Oh, okay. Like it's also wow. A state of time of greatest strength. Really? Not that prime, silly person. And it just goes to defines prime. Really? Okay. Write a program to calculate all the prime numbers up to a given number you entered by the user. Okay. We already have that code. You can just copy it. No, I'm just kidding. We're not gonna copy it. What? Primes below some number, right? So, that's easy. Yeah, that's really easy. Okay. Yeah, now I remembered. So what? Sum of primes. That's creepy. Yeah, we got sum of everything. So yeah. Thisy and Dunny. Okay. No, we want this vector. So okay, in main void, and then now what? We want some end and get the end really. Then successfully see out the sum of all the primes strictly below Rn is something, some magical thing, and slash n and return 0. And it's gonna have sum of primes below n and give it n. Yeah, cool. I don't have that though. Oh no. So so what am I going to have? Oh, long for now. Okay. Long. Yeah, no, long. Okay. Long sum of primes below n, strictly below n. Okay. Not n. We just want int n. Okay. Okie dokie. Okay. So what? Yeah, this. Yeah. So it was, we have a vector of ints called the primes. That is currently equal to 2 and 3, and if necessary. So if necessary. So you had to just say if what, like, I don't know. So if n is equal to 0, or if n is equal to 1, we will have 0. So if it's 2, we need 2. If it's 3, we need 5. Okay. So if n is equal less than equal to 1, then we say return 1. No, 0, because there's no primes. And else if n is 2, then return 2. Otherwise, if n is 3, then return 5. And now we'll take this, we'll say int sum of primes is equal to 5. Okay. We say for in num is equal to 4. It's not necessary, but num should be less than n strictly, and plus plus num. Yeah, easy. Okay. Then we say for auto p in primes. We'll say that if not sum of primes, if num percent p is equal to 0, it's a composite number, and we say composite is equal to true, and you break. And we say if it's not composite, then we say num, right, num, yeah, we need num, so we say primes dot push back that num and total plus equal num. And we also need a bool now, since we have introduced it. Bool composite, done. And we say composite to false. And sum of primes, not total. Okay. Right, so if it's 1, 2, or 3. If it's 1, there's no primes. If there's 2, return 2. If it's 3, return 5. Okay. The 2 and 3, sum of primes is 5. Composite, do 4, and num should be less than n. Yes, plus plus num. Composite is equal to false. Go to your single prime number. If num percent p is equal to 0, it's composite, and break. Others, if it's not, you check every single prime number. So it's not divisible, so itself it's a prime number, so we say that primes will have num, and we add num to the sum of primes. And then after that we say return sum of primes. If I can't write it, yeah, boom, return sum of primes, back here, print it, the end. Okay, cool. G++ minus O sum, oh wait, there's no sum. Chat sum of primes for chat sum of primes, and sum of primes below n is up there, so let's include it. Other than that, we have no problem, so we're fine. Run it, yeah, okay. Chat sum of primes. First start with 0, okay. 1, and then 2, and then 3, and then 4, and 5, and then 6, and then 7, 8, 9, 10, oh no, not 10, 10, 11, 12, 13, 14, 15, 16, 17, and then 18 for now. Guess it's correct, right? So 0, and then 2, and then 5, and then plus 5, plus 7, plus 11, plus 13, plus 13, and plus 17. 17, so correct. Yeah, so it's working. Good. Okay, that's cool. Yeah, we're done already. Wow. Okay. So just copy this again, I guess. User, really? I don't want it, yeah. Give me 10 beginner program. Give me another another 10 beginner problems. Certainly, calc balls and consonants, find the largest number, that's what to, okay. These check leap year, general. Whoa, okay, yeah, cool. Generate prime numbers, already done this. Check for perfect. Enter given by a user is a perfect number or not. A perfect number is a positive integer that is equal to the sum of its proper divisor, excluding itself. Okay. Strong number, okay. Strong number is whose sum of factorial of digits is equal to the original. The sum of the factorial of digits. Okay, yeah. Calculate power. About your number raised to the power of another number using by. Okay, yeah, okay. First, let's count the vowels and consonants thing. Okay. So, chat, count, vowels and non-vowels. Okay, really. Vowels. Okay. And consonants. Consonants. Wow, okay. Yeah. Don't forget to put the .cpp. Okay. So we need iostream. We also need the string library and header file, whatever. std string called s, get the string, and then for auto c and s, we say switch c, then if it's an a, something a, or maybe I can include C type or something. Again, I should include CC type, and then we say that we'll take the two lower of C. Now just give us A or something. And if it's an A, in like vowel, count, plus, same goes for E, same goes for I, same goes for O, same goes for U, not U, vowel count, plus. Oh, like default, okay, we need the default. We have to say if is alpha to two lower of C. So if it's a letter, then it's not any of these. And we say consonant count plus, otherwise nothing. That's it. And int vowel count equals 0, and consonant count equals 0. Yeah. String s, get the s, get these two counts. Now go to every single string, take the two lower of C, let's say A, E, I, O, U. And if that is one of them, then it's a vowel count. And if it's not any one of them, we just need to check if it is alpha. So if it's a character of two lower of C. No, not necessary. We can just keep it like this. Okay. So if it's a number, it will stay a number. Well, like no. Well, just check if it's a letter. If it's a letter, it's not any one of these dudes. So that means that it is a consonant. Otherwise, it's a number or something else, and we don't want to count it down. And then we say our string has vowel count vowels and consonant count consonants. Yeah, S like this, and then each character we get two lower, A, E, I, O, U. And if it's none of them, then we just check if it's a letter. If it's a letter, it's not any one of these, then no, it's a consonant. Otherwise, it's not consonant. And then we say S has number, like vowel count vowels, and consonant count consonants. Cool. Done. So say G plus minus O, check count. Check count. Okay. Check count. Let's say QWERTY. 1 vowels and 5 consonants. And why do we have an extra curly brace, close brace? QWERTY, okay. And we also have A, E, I, O, U, H, G, 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 A, E, I, O, A, E, I, O, U. 10 vowels, yeah, correct. 18 consonants. 1, 2, 3, 4, 5, 6, 7, 8, 9, correct. Okay. Four vowels. Why? A, E, I, O, U. Okay. There's no A, so yeah, there's E, I, O, U. So, and 6 consonants, just because we have 1, 2, 3, 4, 5, 6, 7. 7? 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 6. 6. Yeah, okay. There's 6. Okay. Cool. And they're excluding numbers. Good. That's how you do it, I guess. Cool. Now we got this. Find the largest number. Write a program to find the largest number among 3 numbers entered by the user. Okay. Quite easy. Like, you can just say. Not 4. Chat. Largest number. Let's see. P hash include IO stream and then mean void. We'll say in A, B, C, and then if A is less than B, then B is like, okay, if A is greater than otherwise B is greater than or equal to A, we say, so if A is greater, we say if A is greater than C, then we say that, so we see how A is the largest. Right, so if A is greater than B and A is greater than C, then we know that A is the largest. Although if A is greater than B, but if C, oh no, but how about the same? Rather than doing these checks, can't I just do it in two checks? Like just by doing log 3, I guess. I don't know, but it'll be 3 log 3, which is 6. So, yeah, just why am I overcomplicating this? So find the max against A and B. Right. So see, yeah, so it's easy. So we can say, let's do the if. So A is greater than B, then A and C shall battle. Otherwise, if B is less than greater than A, B and C shall battle. If they're equal, then we say A and B and C shall battle. And how does A and C battle, right? So if A and C want to battle, right? We just say if A is greater than C. If A is greater than C, then we know that A is the biggest. A is the largest of them all. Okay. Right. But else if C is greater than A, then we know that A is greater than B, but it's less than C, so C is the largest, yeah. So C is the largest of all. I put a quick exclamation mark or something. Okay. Return. I don't even need to return because it's going to break and this is going to come out. So return 0. Yeah. Okay. The largest of them all. Otherwise, if they're equal, then we say that A and C okay, what if I just do like this instead? A bit more better by saying, first I need to do the SDC. Three numbers. Here we say SDC out. A, B, and C. And we also want C. New three numbers, A, B, and C. And then if A is greater than B, A and C shall battle. How do they battle? They say A is greater than C, then A is the largest of them all. A, or I'm going to make this very difficult for myself. Okay, or A is the largest number of all. Okay, A space number, yeah, is the largest number of them all. Although C is greater, then we say that C is large. C or C is larger than of them all. Otherwise, if both of them are equal, we say that A and C and like this, put like somebody's value, right? A or something. So A and C, or this value, is the largest of them all. Wow, okay. So if A is greater than B, A is greater than C, then A, value of A, is the largest of them all. If C is greater than A, that means C is greater. C is the largest of them all. And if A and C are equal, then A and C are the largest of them all. Cool. Now, if B is greater than A, then we just take the same thing and replace A with B. Simple. So if B is greater than C, then we say that B is the largest number of them all. If C is greater, then C is greater than of them all. And if they're both are the same, then we say B and C. Say B is the largest of them all. Okay. And last one. A and B will both battle, right? So if same thing, if A is greater than C, right, then we say A and B largest of them all. If C is greater than A, then C is largest of them all. And if both of them are same, we say A and B and C is large. Oh, then we say none of them is the largest of them all. Yeah, smiley face, like, why are you trying to confuse me? And that's it, done. Yeah, cool. What a battle. Okay, so we got A, B, and C. We can say give three numbers, A, B, and C. Then we say if A is greater than B, first of all. Then we say that if A is greater than C, then A is largest, and we put A. Done. If C is greater than A, then A is greater than B, but it's less than C, so C is the greater one, and we put C. Otherwise, A and C, if they're equal, then it's both are overpowering B. A and C are the same. Now, if A is not greater than B and B is greater than A, then we just replace A with B. B is greater than C, then B is, C is greater than B, then B is, C is. Otherwise, B and C overpower A and both of them. Okay. Otherwise, if A and B are equal, then we say A is greater than C. Then A and B, since A and B are both same, are the largest of them all. C is greater than A, then C is the largest of them all. Otherwise, none of them is the largest of them all. Smiley face. Done. Easy. Okay, not easy. Done. So let's do this. So G++ minus O, large chat, largest of them all, for chat. Chat largest number. Okay. So how about 1, 1, 1, then 1, 1, 2, and 1, 1, like, so 1, 1, 1, 1, 1, 2, 1, 2, 1, 1, not 1, oh man. So we go, so let's just type it in Notepad really quickly. Okay. So see, we got same, then we got one of them, right? Then we got two of them. Right. And then we got three of them again, which is this. Cool. No, wait, what? All of them are the same. One of them, two of them, and then all three of them not really. So how should I, like, okay. It's 1 1 1 1 1 2 1 1 1 2 1 2 1 1, okay. And then two are pairing the one, two of them, and then all of them, and then none of, like, one of them again. So I need to do this one. Yeah. Whoa. Oh, I'm pressing insert, that's why. Wow. So yeah, let's do this. Let's first give it 1 1 1. Okay, cool. C, correct. B, A's. Okay, so 1 1 1, none of them. Okay, 1 1 2, C is. B is A is. B and C, A and C, and A and B, and then C. Okay, cool. Cool. So yeah, we got the largest number. Good. Binary to decimal conversion, right? Binary number to its equivalent decimal representation. Yeah. And the decimal to binary. Yeah. Okay, cool. So how to do it? So let's see. Not by looking at the internet. So if I got this, oh god, this, right? We know it works in like some powers of 2, right? So 1 1 1 0 0 something, and 1. No. Wait, does it start from? Where does it start from? Oh yeah, like it does make sense actually. So like this will be 1, then 2, and then 4, then A, and then 60. So like it starts from 1, 0 or 1. So 0 multiplied by 1, and then 0 multiplied by 2, 1 multiplied by 4, 1 multiplied by 8, 1 multiplied by 16. Right, so it's like that. So if I get the string, right, so let's see, if I have, this is a 5 length string, right? So if I start from 4, like this is like, because this is a 0th index, first index, second index, third index, fourth index. If I have 4, I want to have a power of 1. If I have 3, I need to have a power of 1. Wait, no, yeah, 0, 1. So like that. So if I'm on the 4th index in the 5 thing, then we know that we need to do 1, which is 2 to the power of 0. 2 to the power of 0 should be this, so 0, and then 1, and then 2 and 2, 1 and 3, and then 0 and 4. Right, so that's how it is. Okay, cool. So that's what we want, I guess. But how am I going to? Well, actually, if we add them together, we get 5 minus 1, right? So I can type this 5 minus 1, 5 minus 1, 5. Plus base, wait, what? Okay, equal 5 minus 1. Yeah, right. So basically, the formula is input, whatever input or whatever index we are, plus the power is equal to size minus 1. So P is equal to size minus 1 minus I. And that's our P, right? Because we can see I plus P is equal to size minus 1. So if I subtract I from both sides, we get P is equal to size minus 1 minus the current I. And now I don't want to save it. Right? So, right? If 0, we got 0, then it'll have a power of 4. If it's 2, it's going to have a power of 2, 3. 1. Huh? Wait. 5 minus 1, 4 minus 1 is 3. Yeah. 3, and then 2, and then 1, and 0. Yeah. So power is equal to size minus 1 minus I. So based from that, we can solve it. So let's see how. Bin to deck .cpp should include IOStream. I should include the C math library as well. Say int main mian, okay. And we're gonna say int binary string. So like maybe instead of this, we could just have right. So my string std string called binster. And we'll say std cin the binster, right? And then we got an int. Yeah, because we can have like 32 characters, and you know what's going to do for 32 characters, right? Like 32 ones and zeros. So like, okay, so int like deck is equal to 0, and then we say for in I equal size minus 1. Yeah. Binster dot number of bits minus 1. I should be greater than or equal to 0 and minus I. Right, so if we have 4, we want to return 0, which is P is equal to size minus 1 minus I. So we're going to say deck plus equal the bit, right? But we can't just multiply the bit, right? It doesn't work like that. So
Getting bored?
no.
How much more is remaining?
Well, we have binary to decimal.
So you create more problems?
Yeah.
Why would you do that? Okay. Yeah, but like, did you like finish the 5 of them in the first batch?
Yeah.
You finished them. You created more now. Okay. It's a long work to go. But again, you could have done this tomorrow actually. Like next batch.
Oh
Because
yeah.
you have badminton match.
Yeah.
By what time you take a break?
Yeah.
Yeah,
Okay.
whenever, like whenever you feel.
Yeah. So yeah, we'll do this later. We'll see you in the next session. Bye bye.